Hey everybody, it's Mr. Wolf. Welcome back to another video on the unit. I hope you guys are enjoying the unit thus far. Honestly, this is some pretty interesting stuff to me. I don't know how you guys feel about it, but we're going to be covering a lot today, so make sure that you pause anytime you need to make sure you get all of your guided notes filled out. And remember that you can come back to this video anytime during the unit to review and get any information that you feel you may have overlooked or missed out on. So let's get into a little bit of review before we jump into the new topic. So we want to get a definition for quadrilateral. I'm sure you guys know this. We've said it 100 times already, but a quadrilateral is any four-sided polygon. So you can think of squares. One example right here, a parallelogram, which we will define. Squares, rectangles, any four-sided polygon is a quadrilateral. So what is a parallelogram? Well, let's visit next slide here. Parallelogram is a quadrilateral that fits these properties. The opposite sides are parallel. The opposite sides are also congruent. The opposite angles are congruent. Consecutive angles are supplementary. And lastly, the diagonals bisect each other. Let's review what each of these mean. Opposite sides are parallel. That means, as you can see in this little picture here, that this side parallel to this side, and this side is parallel to this side. Opposite sides are congruent. We can see that this side is parallel or congruent to this side, and this top one is congruent to this bottom one. Opposite angles, this angle is congruent to this angle. This angle is congruent to this angle. Consecutive angles are supplementary. That means that this angle here and this angle here will add up to 180. Or this one and this one, or those top two by themselves, or even the bottom two. Any back-to-back angles will add up to equal 180 degrees. And then lastly, the diagonals bisect each other. That means when you draw these diagonal lines connecting corner to corner, they will bisect each other, breaking up the segment into two equal parts. For example, that is congruent to this, and this is congruent to that. Just a little review because these properties are going to be coming in handy throughout everything we cover today and on further in the unit. So let's talk about the rectangle. Now, I'm sure you guys have seen rectangles. You guys know what rectangles are. They can come in all kinds of shapes and sizes, wider, skinnier, longer, all that good stuff. But let's really talk about what a rectangle is. The most important thing to know about a rectangle is that a rectangle is indeed a parallelogram. Now, I know that sounds weird. Say that one shape is another, but if we revisit these properties, opposite sides are parallel. Let's just look at these and take a guess here. Well, do those sides look parallel to me? Opposite sides are congruent. Yeah, looks right. And I don't have to go through all of these, but it goes to say that each of these properties that is true for a parallelogram is true for a rectangle because guess what? A rectangle is a parallelogram. It's not just any parallelogram, though. The biggest and most important property, once you've understood that it's a parallelogram, is that it has 90-degree angles. We'll use this top rectangle as an example. That means all of these angles, every one of them, is always going to equal 90 degrees. That goes back to our parallelogram properties that we said consecutive angles are supplementary. Well, if all of these are 90, 90 and 90 is 180. So any way you add those up, you're going to get your supplementary angles. And another fact here is that all the angles are equal, meaning that the opposite angles are equal as well. This is just basically a special form of parallelogram. So a rectangle is a special form of parallelogram, and I repeat that because it's really hard to grasp that one shape could also be considered another, and we're going to see more of this. So remember that rectangles are indeed parallelograms and will always have these 90-degree angles. So from that, let's look at what we can do here. So we know that this angle down here is 90 degrees. This angle up here is 90. This angle here is 90. All of these are 90. And then another property here. One property that I haven't mentioned yet that is very important to rectangles, and it's special to rectangles. So no matter how big, how long, whatever way you shape a rectangle, the diagonals of those rectangles, or a rectangle, is always going to be congruent. So diagonals are congruent. Now, this isn't to get mixed up with diagonals bisect each other. Although that's true for rectangles, diagonals of a rectangle are also congruent, meaning that line segment AC is congruent to line segment BC. And this provides some really interesting stuff. Since we know this, and we know that the diagonals bisect each other, we can say that all of these individual line segments are congruent to one another, which is pretty cool. And then we also said that it has congruent opposite sides. So we know this side's congruent to this side, and this side is congruent to this side. So now you can see it's formed from triangles here that are congruent to one another, which is really cool. And we'll do some work with this. So here's an example of doing some work with using the triangles formed or that form a rectangle. So can we find the measure of angle AEB? AEB is right here. Given that DAE, that would be this angle, is equal to 53 degrees. 53 degrees. So let's think about what we know here about rectangles. Let's go back to what we talked about on the last slide. We said that because we know that these diagonals are congruent and they bisect one another, we can say that all these sides are congruent. But let's look at what that forms. If we say, let's look at this AED triangle. Well, if this side, right here, and I'll highlight it again, and this side are congruent to each other, then that means, with this base along the bottom, that this is an isosceles triangle. So let's go back. Let's see what this says. So what's special about isosceles triangles? Well, the legs are always congruent to one another. So we can say, in this case, that this side and this side are congruent, but also the base angles are congruent. So we can look over here and say, well, this is 53, and this is also 53 degrees. And then we can do some really interesting stuff because we know that all three angles of a triangle add up to 180 degrees. So let's add up our two 53s we have. And that'll get us 106. Then let's subtract that from 180. See what we have left. 74 degrees. So that must be what this angle equals. And then if you follow the properties, like we said earlier, that, well, when you mark out all these sides, this triangle is going to be congruent to the bottom one because of the way the sides line up. You can do that by side, side, side. So that means this angle is also 74 degrees. And then that also means that this one is 53 and this one is 53. Now, we may have a little bit more information than we need here to solve this problem. But it's always good to have more than not enough. So let's erase our work we've done here and make room for the rest. So what are supplementary angles? Supplementary angles are two angles that add up to 180 degrees. So right here, this line right through here, that's a straight line that is broken off into an angle by this line. So we know that 74 degrees and whatever AEB is equal to are going to add up to 180 degrees. So what we can do here is 180 degrees minus 74 degrees, and we will get 106 degrees, and that's our measure for AEB. So angle AEB equals 106 degrees. So it's really cool what you can do with the triangles formed by these rectangles. There's a lot that you can do with them that you may not have thought you could. Another quick thing I think it'd be important to address here is that this is not a necessarily to scale drawing. As you can tell, that AEB doesn't necessarily look like 106 degrees, but these are just random numbers that I plugged in for an example. But remember all these properties because you can get all the information about each angle and each side just by throwing a couple things you've learned in. So remember those properties. They're very important. So how can we determine, that is a typo, but how can we determine a parallelogram is a rectangle? So let's think about this for a second. We determine that a parallelogram is a rectangle. Well, let's look at the properties we've made. We've said that back here in the definition, we said, well, a rectangle is a parallelogram with 90-degree angles. We also said that its diagonals are congruent. So given a rectangle and the question is this, or given a parallelogram and having the question is this a rectangle, you can look at those things. Are the angles all 90 degrees? If so, if we have 90-degree angles, and if that is checked off, then yes, it is a parallelogram. Then what about this? What if the diagonals, and that is a very crude drawing, but it will do for now. What if we say the diagonals here, like line segment AC, congruent to line segment BD? Do we have that? And if that's true, then yes, it is a parallelogram. So remember those properties. Remember what makes a rectangle special in comparison to a parallelogram. So rectangle review. I know this may seem like we're beating a dead horse here, but rectangle review, it is a parallelogram. Is a parallelogram. That is very important to understand. All rectangles are parallelograms, but not all parallelograms are rectangles. So what can you use to determine if a rectangle is a parallelogram? Well, you got to check for 90-degree angles and congruent diagonals. These are really the big three takeaways here, is that a rectangle is a parallelogram with 90-degree angles that has congruent diagonals. And in knowing these things and the properties you know about parallelograms, we can do stuff like we did here and here and here to determine and answer questions relating to the triangles that are created, the angles and whatnot. And you can really solve a lot from such a simple list like this. So we're on to yet another quadrilateral that is known as the rhombus. Now this one is a tad odd because you look at this picture here, this right there, and you think, well, that is just a parallelogram, right? Well, you wouldn't be wrong in a sense, but let's explain exactly what a rhombus is. Once again, a rhombus, just like a rectangle, is a parallelogram. We're going to have several shapes that fall under this category because all of those properties, that chart we've showed 100 times now, all of those properties apply to this shape, the rhombus. So it is a parallelogram, and just like the rectangle, it's a special type of parallelogram. A rhombus has 4 congruent sides. Meaning, this side is equal to this side, is equal to this side, is equal to this side. So 4 congruent sides, and it's a parallelogram. Well, what else? Rhombus has diagonals that are perpendicular. And just for those of you who may forgot, perpendicular refers to any time 2 lines cross each other and meet at a 90-degree angle. So let's look at this. Here's an example. This is a rhombus. As you can see, all sides are congruent to one another. Then we have these diagonals that meet at 90-degree angles, making them perpendicular. And I'll erase this to show that this one is well over here. This one is well over here. I guess we can do all of them here. Draw like a little square here in the middle. All of those are 90-degree angles. And that gives us some information that we can solve stuff with. But there's one more thing that needs to be made note of here. That is that rhombus have diagonals that bisect the interior angles. Let's think about what that means. Bisect. If an angle is bisected, say we have this angle here, and we'll give this as a crude drawing of a bisector, that means that the two angles it creates, this one here and this one here, will be equal in measure or congruent. So when something's bisected, an angle is bisected, it's separated into two equal angles. For example, if we have angle DAB, that would be this outer one down here to the left side. We have angle DAB. It is bisected by line segment AC, creating two equal angles of DAE, be congruent to angle BAE. So that bisects the interior angles. The same goes for line segment BD with angles ABC and the angles that it's created there. So, what can we do with these things? Let's just do it here. Let's say, you have a measurement here. Let's give something like 24 degrees, something like that. And you want to know, well, what does the whole angle equal? If you know that angle ABE, let's just write this out. ABE equals 24 degrees. And you want to know what angle DAB equals. How do we get that? Well, we know that this bisects those angles, so we know that this angle is going to be congruent to this one. So this one must also be 24 degrees. And then if we add those together, we can conclude that angle DAB equals 48 degrees. So how do we determine if a parallelogram, another typo, there we go. How do we determine if a parallelogram is a rhombus? We have a parallelogram, we say, okay, rectangle, or is this a rhombus? How can we differentiate? Let's go back to what we just learned. A rhombus has 4 equal sides. So if we have this, we see that these 4 sides are equal. So 4 equal sides, or congruent would be the best way to say it. 4 congruent sides. If this is the case, then yes, it is a parallelogram. Other things, we have these diagonals. Those are actually better than the ones I drew before. And we see that those diagonals meet at a 90-degree angle. In other words, they are perpendicular. So diagonals perpendicular. If this is the case, then yes, we can say that it is, in fact, a parallelogram. The rhombus review. Let's go through this all again. A rhombus is a parallelogram, just like a rectangle is. It has 4 equal sides. Or what's the word? Congruent sides. Congruent. It also has diagonals that are perpendicular. And lastly, those diagonals also bisect interior angles. So on top of all those properties we've learned about parallelograms, this chart we keep referring to, on top of all the stuff in this chart, you can add this information to what a rhombus is. And that's why we keep repeating these things, because it's a lot of different properties, a lot of different things to differentiate between very similar shapes. So these are things definitely to make note of, even further than your guided note. So maybe write these down all in one sheet, separated into like a chart of the properties that apply to parallelograms, and then ones that apply to both parallelograms and rectangles, and then both parallelograms, rhombuses, because that will really help you when reviewing for the test. And we're going to move on to the last shape of the day, the square. Now, I feel like this one would be the one you guys are most familiar with. I feel like these the properties we're about to look over are something that you probably could have had a good guess at, but maybe not. So let's review. So, definition of a square. Well, believe it or not, a square is, you guessed it, parallelogram. We've said that word 1,000 times. But a square, just like a rhombus and just like a rectangle, is a parallelogram. Here's another fun fact about a square. A square is not only a parallelogram, a square is also a rectangle. Now things are just getting weird, but guess what? They get weirder. A square is also a rhombus. So, it seems funny, it seems weird, but rectangles and rhombuses, or rhombi, are parallelograms. Squares are all three. Well, four if you count it being a square as well. So, a square, let's repeat, is a parallelogram, a rectangle, and a rhombus. But it's kind of a special form of all those because it's got its own properties. First off, well, since it's a rhombus, we can say it has four congruent sides because we learned that much. And since it's a rectangle, we can say, well, it's got all 90-degree angles. Since it's a rhombus, its diagonals are perpendicular. And since it's a rectangle, the diagonals are congruent to one another and they bisect each other. So all of the properties we've covered for parallelograms, rectangles, and rhombuses convert to squares. So let's look here for an example. Just some information we can get. We can say, well, we know all the sides are congruent, so AD is congruent to DC, is congruent to CB, congruent to BA. Okay, we know that much. Well, it's a rectangle as well as a parallelogram and a rhombus. So we can say, well, rectangles have diagonals that are congruent. So we can say, well, DB is congruent to AC. We know those diagonals bisect each other. So BO is congruent to DO. And because those diagonals bisect each other and the diagonals are congruent, we can also tag onto the same chain of congruency that AO is congruent to CO. So BO is congruent to DO, it's congruent to AO, it's congruent to CO. And that is difficult to say, but knowing all these properties, we can just apply them to one shape. So it's really cool because you've learned all this stuff and you learn to differentiate it between squares and rectangles and parallelograms and whatnot. But with the square in particular, everything applies that you've learned so far. So you can put all of that to the test. Let's see what else we can say here. Well, we can say that angle A equals, no, we got to be careful. We got to say angle BAD equals 90 degrees. And you know what else equals 90 degrees? Angle ADB, or ADC, I should say. Angle DCB. And I think you're getting the point here, is that all of these apply. And I know this is a very repetitive lesson, but these properties are all applicable applicable to different things in different ways. So it's very important to understand how these all work. So let's look. How can we determine that a parallelogram is a square? So let's think about it. How could we determine if it's a square? Well, let's say, it has 90-degree angles. Well, that makes it a rectangle for sure. And then it has 4 congruent sides. Well, that makes it a rhombus as well as a rectangle. But it can't be a rhombus and a rectangle. But what can be a rhombus and a rectangle is a square. So that's how we would determine it. You look for a combination. We'll write this down. How do you determine if a parallelogram is a square? You have to find a combination of rectangle and rhombus properties. So let's give another example. Instead of saying, well, 4 sides are equal and all angles are 90 degrees, let's say you know that the diagonals of this are congruent to one another as they would be in a rectangle, but you also know that they meet at 90-degree angles, making them perpendicular, which is akin to the rhombus. So in that case, you can say it's a square. The square is a little bit harder to narrow down than the other two because you have to find a combination of those properties. But if you know your properties well from the others, this shouldn't be too difficult. Square review. I know we've said everything. We're not going to exactly say this before. This last slide is going to be a little bit special. So let's look at everything we know. We've learned about polygons. Polygons are shapes with lines and all that good stuff. I think we've reviewed that definition. And then you can break that down into quadrilaterals. And then quadrilaterals has its whole own tree of things. One of those being parallelogram. But a parallelogram has its own tree that splits off into rectangles and rhombi. But then guess what? Those branch off into the square. So let's look at this. Squares are not just squares. Squares are rectangles, rhombi, parallelograms, quadrilaterals, and polygons. So a square is everything you see in this tree. Rectangles and rhombi, those are both parallelograms. A rhombi and a rectangle are two different things. They are not each other, though. Rectangles are parallelograms, rhombi are parallelograms. Parallelograms, quadrilaterals are polygons. So we can look at this tree. I suggest drawing one of these out yourself, and it may help to maybe, stick with the words up here, the polygon and quadrilateral, but maybe draw the shapes out as you go down to help you remember. This tree will really help you classify what is what, because it's not just remembering the properties, it's remembering what the properties apply to. So keep that in mind as you go through. I hope this lesson helped. If you need any help with anything, make sure you hit up the Google Meets we have every day during class time. If you need to get a hold of me or Mr. Rose, feel free to email us. And I hope that this video helped some. If you need anything else, make sure to contact us. And make sure to get those guided notes filled out.